about the force. If you look over in these pictures, you can see that they will use force to change direction or to stop the ball or to move the ball with the velocity and the acceleration. Now we can realize that the force is an action will exert on the object to change motion or to make rest for this object. Okay, now this action, it will exert in object to change motion. Okay, now that is the definition of force. Now the force will uh, uh, we can find the force by using the unit Newton. That is the Newton of force, and Newton equals kilogram meter per second square. Or we have another units of force. This is the system international unit for force, Newton. Okay, now we have another unit of force units. Dyne, it equals gram centimeter per second square, and lb here means bound. Okay, and bound equals slug divide slug feet per second square. Okay, yeah, this bound, and lb come from libra, that the bound by Latin word. Yeah, bound by Latin word, it will become libra because the bound symbol is lb. Okay, guys, libra or bound to Newton, you make multiply 4.448. Okay, that's written here in your book. Okay, page 119. Okay, guys, and if you want to make the opposite from Newton to pound, you make divided by. From the bigger to smaller, you make multiply. From smaller to bigger, you make divided by. From pound to Newton, multiply. كبير يضرب الصغير. From Newton to the pound, divided by. Okay يا شباب. And we take the two kinds of the force. We have contact force and field force. Contact force, very simple. Contact, we have touching between the object and the another object make the force. Okay, if you look over for all of these pictures here, all of them are contact force. Can you see the stick will contact with the ball to change the motion? Now this hand will contact with ball to stop the ball. Now the girl hand will throw the ball, and now this is the contact force. Okay, now all of these are examples of the contact force. That the first type of force. The second type of force is field force. Field force, we do not have connection. We do not have touch between the force and between the object make force and another object. Okay, no touch, no connection between them. This is called field force. Like electromagnetism force, like the gravity, of course, like the atoms. Inside the atom we have electrons and the atom itself. All of that are field force. Okay, you can write here, you can find here, guys, these very important notes here in your book, page 119. All of them are four fundamental field forces. We have four fundamental field forces. Okay, yeah, we have four fundamental field forces that are gravity, electromagnetic, and also atomic force and weak force. These are the four fundamental field forces. Okay, guys. Now, any questions?
So you need us to
Yes,
underline
Mister.
what?
Yeah, yeah. Underline this last part. Yes, underline it. Yes,
Mister, can I ask you something?
yes, please. Yes, ask, please.
Can you go up a little bit?
Yes, of course.
When it was around the pound and the new,
Yes.
the new.
Please raise your voice up, please. I can't hear you well.
Okay, 1 second.
Yes. Yeah. What is your question?
Okay, this is good now.
Yes, yes. Better. Yes.
Uh, uh, do we measure the force by 1 Newton?
Yeah, 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 yeah. That's the system international unit for Newton for the force. Yes.
We measure it by pound. I mean,
No, no, no. In our problems, we don't use bounds. Okay, but this is the some units of force you should to know, and you should to know how can you convert from bound to Newton and the opposite. Just it. Okay.
Mister, but a Newton is like energy. How can it be converted to like pound, a weight or a mass?
Yeah, it's not energy. We have difference between energy and force. Newton for force, not for energy. Energy will be different.
Yes, force isn't. How force will to be to mass?
Yeah. Now that's good question. Now, because if you look over for the weight, okay, I explained that in the last session. Now, if you look over for the weight, for example, okay, now weight equals. We explained that in the second Newton, the second law of Newton. Just a minute. I will open my pen. Okay, if you look over for the second Newton of second law of Newton, okay, now you can see that here we have the weight, okay, equals ma or mg, okay, m here that is the mass, and g here this is the gravitational acceleration. Okay, now this is your mass by kilogram and gravitational acceleration by meter per second square, because that's written here. Okay, yeah, it's a kilogram meter per second squared. Now, a weight, it will be count bar by the Newton, and the mass by the kilogram, and gravitational acceleration by meter per second squared. That's just it. You understand now?
Okay, okay.
Okay,
Can
thanks
we
for asking.
solve problems for
Yeah,
it?
yeah. We have a problem. Yes, and you have assignment.
equal
Mr.
Yeah, you
equal
have
by
assignment, guys,
the second.
and I will tell you something about the assignment at the end, because maybe you have a problem in the assignment. I will tell you at the end, inshallah. Okay, guys. Anyone
Mr.
have another problem, guys?
Yes.
Yes, Habibi. Yes.
What is slug?
Yeah, that's the unit of the kilogram, like the gram. Okay, like gram, like feet. Okay, now we can account the distance by feet, by centimeter, by meter, by kilometer. All of that are units for the distance, and also the mass. We can use different units for mass. Okay, some of them called the slag. Okay, like bound. Some of the forces unit is called bound, and also some of the masses unit called
Okay.
slag. You can search how much the slag it will be. Just it. Okay. Khalas, do you understand, or you have another question? Okay, Ashab, now I will
No.
start with the new lesson. Okay, now guys, as I told you at the beginning, this section very easy, I think. Okay, guys, and now let's move for the second uh, lesson for today, the force diagram. To understand more about the force, you should to draw the problem. Okay, now at the beginning, guys, I will ask you a simple question. If you know the answer, open your microphone and answer. No problem, guys. Now, the force, it will become vector quantity or scalar quantity. Hiya, Shabab. Open your microphone and answer, please. Force, vector or scalar?
Victor.
Yeah, excellent. Another answer, guys. Yes, Abdurrahman.
Yes, Victor.
Yeah.
Victor.
Give me your answer. Yes, excellent. Yes, Yaid. Do you have an answer, Yaid? Yeah. Baha. Do you hear me, Baha? Baha.
Yes,
Yes, my friend. What is your opinion about force? Vector or scalar?
Still, I have opinion.
Victor.
Yeah, Victor. Excellent. Yes, Abdurrahman. What do you think, Abdurrahman?
Why, Mr. It's Victor? Victor depends in direction and
Excellent. Excellent.
Yes, Mr.
Yeah.
first is only magnitude.
Very good, very good. Yeah, very good question. Listen to me, Abdurrahman. Okay, now, guys, our friend asked me why Mr. Force will become vector quantity. How? We just have a magnitude. Okay, but in fact, of course, we do not have a magnitude. We have direction also. Now, this object ball, okay, on the wall or on the land like that. Okay, now in this surface, now the ball will attract it down by gravity. Now I said that down. Can you hear me? Down. Now we have a magnitude down. Now it's a vector. Okay. Now if I exert on this ball to this direction, okay. Now I will kick the ball by my leg, for example. Okay. Now in this direction to the east. Okay. Now can you hear that? Now I will exert to the east. Now the direction, because
Yes,
of the
sir.
force we have magnitude and direction. Yes, yeah, Ahmed.
Scalar is the same as vector, but vector has direction.
Yes.
Okay.
Yes. Okay, guys. Now, because that the force, of course, it will become vector quantity. We have a magnitude and a direction for the force. force is a vector quantity, and we can draw the vector force like that by this arrow. This line will represent to the magnitude, and the tip of this arrow represent to the direction. Okay, now, and when this become taller, it means we have larger of the force like that. Okay, now we can draw a force as an arrows like that, guys. Okay, now in general, force is a vector quantity. We have a magnitude and direction. Anyone have a problem, guys? Excellent, excellent. Okay, guys, now
Yeah.
let's move for how can we draw a force. Okay, look over for this car here down. Okay, now this one and the other one. Let me to open the PowerPoint. Yeah, okay, guys. Now, as I told you, the force, it will become vector because we have a magnitude and direction. Okay, guys. Now, what about the force diagram? Okay, guys. Now we have two kinds of forces diagram. We have force diagram and free body diagram. Force diagram and free body diagram. Okay, what the difference between both? Force diagram, we will draw all of the arrows in all of the action. Okay, but in free body diagram, we will focus just on the body, on the object. Look over for this picture to understand. Okay, yeah. Okay, now this is the force diagram, guys. Okay, now we have car, and this car will exert on the wall, okay, with the force. That is the force come from the car, okay, and this wall have weight. The weight of this wall will be looked down like that, okay, and we have something called normal force. Normal force. The normal force, guys, every time it will be perpendicular to the surface. Normal force every time will be perpendicular to the surface, and we will understand more about the normal force in the third Newton's law. Okay, now like the gravity will pull down the wall, also the surface will exert up on this wall. It's called the normal force. Okay, guys. Now that is the all forces for exerts on the wall. What about the car? Now, like the car will exert on the wall, also the wall will exert on the car, because that sometimes you can see the car will damage from here. Why? Because we have outside exerting, okay, like that. Now here also the car have weight, and the surface will exert on the car up. That is the normal force. Okay, that is all forces for all the action in this diagram. Okay, now this is called force diagram. In other hand, the free body diagram, we will focus on just the object. We are talking about the car. Okay, we will focus on just the car. We don't draw anything else. Okay, now how much the forces will exert on the car? Weight and normal force, and the wall will exert on the car. Just it. That is the free body diagram. That is the free body diagram. Okay.
Consider the situation shown here. To completely understand the motion of the toy, we will identify each force that acts on it. We begin by drawing a free body diagram. A free body diagram isolates the object in question and identifies each force that acts on that object. Let's draw a rectangle to represent the toy. We don't need to draw any of the items that touch or act on the body, such as the ramp or the rope. Next, we identify and label each of the forces that act on the toy. First, consider gravity. The direction of this force is always straight down. We will label it F sub g. Now let's consider the contact force between the toy and the ramp. Contact forces always act in a direction perpendicular to the surface of contact. The word normal means perpendicular. Physicists refer to contact forces as normal forces in order to remind them of the direction that the forces act. Next, we think about the rope. Ropes cannot push, they can only pull along their length. The direction of the force on our free body diagram will be drawn accordingly.
Excellent. Okay, guys, that is the example of the free body diagram. It's really amazing to understand. Okay, I'll explain it again, guys, here to understand how can we draw the free body diagram for this toy. Okay, now we will draw a toy like box. Okay, we will draw it like box, guys. Okay, now like that. That is the toy. Okay, now we will make point in the middle. Okay, and start with the gravitational force, the gravitational acceleration or gravitational force. Okay, it will exert vertical every time down like that. Okay, this is called Fg. Okay, now what about normal force? The normal force will be perpendicular to the surface, to be like that. That is the normal force. Okay, now we have another force, pull it up. Okay, now it will be like that. Okay, now this is the force come from this rope. Okay, that is the free body diagram for the body, for this object. I will explain another problem. Any question? Now from the book, page 100, 121. Okay, if you want to open with me, and I will draw this problem. Okay, now let's look over for this problem. Okay, a photograph at right shows the person pulling a sled. Draw a free body diagram for this sled. Okay, the magnitudes of the force acting on the sled are 60 newton by string. Okay, that is the string. Can you see this picture here? We have string and we have sled and this pulled by this man. Okay, now how can we draw this problem? Okay, at the beginning we will draw this object like box. That is the object, and we will make a point in the middle. And after that we have 16 newton by string in this way like that. Is a vector of 16 newton. We can write here just 16 newton. Okay, and 130 newton by the earth. It means like that. The gravitational force. Now 130 newton and 19 newton upward. It means the normal force. To be like that, guys. 90 newton. Just it. Now I have finished. Any questions for this problem? I will explain another. ها شباب.
Yes, can you repeat for another problem if you can,
Yes, of
please?
course. Okay, anyone still have a problem, guys? Okay, let's answer another problem. Okay, now this problem also very easy. Okay, guys, just we are drawing. We are explain how can we draw. Very easy. Okay, now we have track and the trailer on the flat station of road. The force acting on the trailer. Now we have the trailer. Are the force due to the gravity. Now the trailer like that. Okay, and this is the box of trailer, and the gravity will pull it down by 250,000 newton. Okay, downward it will be like that. Okay, 250,000 newton down. Okay, and the force exerted by the road, it means the normal force upward, it will become 250 up. Can you see that, guys? Here we have some notes. Can you see that most of time the normal force will be the same of the gravitational force if we do not have another force in the angle. Just this is a simple note. We will talk about that more in the Newton's law and like that. Okay, I just give you a simple note. Okay, now here upward or the normal force will become 250,000 newton. Okay, and the force exerted by the connection or connecting the trailer. Can you see this connecting? It means we have connection. This is the contact force. Okay, to the track. Yeah, this to the right. Can you see that? To the right, like that. Okay, to 20,000 newton. Okay, the force acting on the track are the force due to gravity. Now we have track also. This is another object. Now this is the trailer. We have track. This is another object. I will change the color. Okay, yeah, this is the track. Will be like that. Yeah, we have downward 80,000. Okay, downward 80,000 for the track. Okay, and the force exerted by the road 80,000 up, like that. 80,000 up. Okay, and the force exerted by the cable come from the trailer to the lift. Okay, it will become like that, 20,000 newton. Okay, and the force causing the track to move forward, it means to the right. Okay, it will be larger than this, equals 26,400 newton to the right. That is the problem, guys. I have finished. Okay, guys, have a nice day. Have a nice weekend. See you next time, inshallah. Thanks a lot, guys. See ya. Salam.